Thank you so much. So the title of this research, by the way, I'm Aris Soleta. I'm one of the PhD student from the LSU Graduate School of Economics. So hoping to finish my degree this year. Pray for me for that particular matter. So just an explicit disclaimer. The view expressed in this paper is solely of mine and not necessarily represent those of this LSU School of Economics and of others. Next slide, please. So currently, we are battling great uncertainties on the prospect of growth. Major economies, large and small, experience different economic problems. In particular, the Philippines, lastly, that we recorded, there's like 19% contraction onto our GDP. So the problem is that how can we recover from the pandemic? So the government is planning to increase spending. Currently, the government already planned in the start of this administration to increase government spending, but they're still planning to increase it more. I think around 10% of the GDP to increase the deficit and increase the borrowing. Now, the problem is that there's really a great debate whether these particular tools of fiscal stimulus will have a particular effect to the economy. And that is our question. Our questions to wanted to answer to this particular research is the public investments on infrastructure have any positive yield or externalities on private investments? In particular, we also wanted to check the impact of increased fiscal spending on different macroeconomic variables such as output, employment, and inflation. Next slide, please. So just to give a background of the studies or of the literature, there were several literatures that are going through with this particular subject as well. One of them is Rami and Ushers in 1989 and 2020. So this highlight the potential of long-run infrastructure as policy tools. In their particular neoclassical models, what they have is that they have what we call public investments as part of the CS production functions. So if you're familiar with your macro models, you have output is the functions of your capital, labor, and now what they did is that they separated capital into two parts. One is private capital, and the other one is public capital. So what they did is that they say that in the long run, this public capital is accumulated and provide what we call productivity boost to the output. So in similar ways, in 2019, one of my professors, Lim 2019, have done the same, almost similar studies on these particular matters. But instead of like a public health problem, what he noticed that is that in the Philippines, if you will notice, the Philippines always been encountered by hurricanes and storms. So what he did is that he asked the questions. So what is the result of government spending in an economy which have a government productive capital? So most of the papers that we have in the Philippines are actually on any classical models have assumed that public investments and public policy don't have any interactions or don't have any policy implications. So what he did is that this is a different way. The other papers that are also similar with Lims and Rami is on Lepper and the Kuikuy and Sauler. In their papers, so what they're trying to study is that what will be the impact of delays on public spending. So let's say that there's a procurement, there's a planned infrastructure projects, that what if there's a delay, like a legal battle or legal setback? So what they said is that timing is very important. If we have some delays onto this particular infrastructures, the social benefits will also be delayed. So basically, what common to the literature is the incorporations of what we call productive government capital, in which I will be explaining more in our model. So next slide, please. In this particular study, I use neoclassical models, in particular in the Keynesian traditions. So the slide that you are seeing now, equation 1 and equation 2 are representing the household budget, household objectives, and equation 2 is what we call the household household budget constraint. Just to quickly explain that, the equation 1 is basically consumptions, which is city, and H is the habit parameters, and L is the labor. So we're trying to look at the lifelong lifetime utility functions of the consumer or household rather. Equation slide number 2, Next slide, please. So this next slide is that in the neo-Keynesian traditions, there's what we call intermediate goods and final goods firm. So the final goods firm are producing the product using a Dixit-Stiglitz technology aggregation. So I don't really want to go to details, but if someone wanted to ask, I can share the paper's details about this. So equation 4 and equation 5. Equation 4 talk about the maximization, and equation 3 is the inputs of the profit maximization of the firm. Equation 5 and 6 is the result, in which equation 5 is the intermediate goods firm demand for product, and PT is the intermediate goods firm prices. Next slide, please. This is the following slide is the exposition that we use is similar with Villaverde and Ramirez. So I just wanted to dig over to equation number, the first equations on the slide. So if you notice, as I mentioned you earlier, so what we did here is that the production functions is represented by AT, which is the productivity parameters of the firm. And production function now is composed of two kinds of capital. One is KP with superscript of P is the private capital, and KG with the superscript of G is the government capital. If you will notice, there's alpha and 1 minus alpha on labor and capital, private capital. So these are the parameters that measures the share of government shares of private capitals and labor to the production functions. We also induce the production function by having the alpha G parameters with the subscript G is the parameters that measures the influence of government capital to the overall production functions in the economy. So imagine that your roads and your airports and your seaports and etc. That is your government capital, and we're trying to look at the externalities that it can produce over to private capital and ultimately to the overall production in the economy. So this is really a theoretical and an empirical works, by the way. So if you do the cost minimization problem of this firm, you will produce 9 and 10 and 11. So 9 is a capital demand, and 10 is the labor demand, and 11 is the marginal cost of the firm. Next slide, please. So this is a really long computations. I really didn't put everything in the slide, but basically equation 12 and 13 is telling you the what we call this the Kalber pricing mechanism. So imagine a firm that there's a shocks on their demands or in their supply, and the questions that we have is in the real business cycle models, the early real business cycle models. The classical economy tell us that this firm can instantaneously change their price, but the rethinking of many economists having into the new Keynesian traditions like mine, believing that there's what we call sticky wages and sticky prices. In this particular models, we don't do sticky wages. What we do is a sticky price. So what it means is that if there's a demand shock or a supply shock, these firms cannot quickly adjust their prices. And if you will notice that the psi parameter 0 to 1 governs the optimization. If it is 0, it means that there's no firm optimizing there's no firm that are indexing their prices on the previous price. So in the literature, we call it the menu price. So equation 14 is what we call the aggregate price in the economy. Next slide, please. So this is where we're trying to focus with. So this is the government budget constraint. So the government budget constraint purchase consumption and investment, and it pays for the debt it borrows from the previous period and the transfers. This should match on to the government taxes that collected from the economy. Next slide, please. Next slide. So we're trying to look at different fiscal rules. So the first fiscal rules tell us that government spending responds to output. The second term is about deficit over output, and the last term is what we call the GDP, debt over to GDP, and the last term is what we call the shock in government spending. The second rule is actually the same, except that now deficit and debt to GDP is being calibrated using a particular target. The last part of the equation is what we call the monetary policy response reaction function. So this is actually interest rates, and the economy responds to the previous or lag value of its interest rate. value. The next term is what we call the output gap. The last term is what we call inflation against its inflation targets, like we had in the Philippines. The last one is what we call the interest rate shocks. Next slide, please. So this is the interesting part that we wanted to understand. So I do what we call Bayesian estimation. So in the literature, I use output, investments, debt to GDP, and consumptions and inflations in estimating this model. So the model, based on our estimations, if you will notice, the posterior mean, this is where we're trying to focus with. The first one is output to deficits, which is 0.18, 0.13 for deficit to GDP, debt to GDP. If you will notice, there's almost 0.91 a value for the debt to GDP. This is actually not surprising because in the Philippines, we had an automatic stabilizing clause, which means that every time that we're trying to do our budgets in the national government, we always prioritize paying our interest payment. And aside from that, before any government entities in the national government can borrow from externally, they have to submit a paper or a feasibility plan to the Bangko Sentral of the Filipinas, and Monetary Board should have approved it first before it can be done. The next part of the slide is actually what we call the estimates of the monetary rule. I wanted you to point your attention over to the inflation which have the value of 2. If you will notice, this result is basically based on the framework that we changed in 1997, I think, from aggregate targeting over to inflation targeting. Next slide, please. So the next couple of slides is about what we call the impulse response functions. So what is an impulse response functions? So it's trying to explain to you at a steady state, this is the value of a particular variables. If there is a shock, where it will go in certain periods. So this is, by the way, in terms of quarters. The value that I have from time series is annually. We divide it by 4 to get it to make it quarterly. So if you will see, the first slide shows you the effects of the technology shock. What if there's a productivity boost? There's the technology shock after the pandemic. What will happen? According to this slide, you will see that the technology shock produces a positive effect on output, a negative effect on consumptions, and on hours. It's also it dips and then it goes back to its steady state. One particular thing that we wanted to notice here is that the productivity shocks resulted a decrease in debt, which is B. An initial steady state value of deficit, then it increases the deficits. That's what we're seeing now. Government spending decreases as private investment are more employed in the economy. So what happened here is that as the economy have more productivity shock over to the private sides, policy tools will say that government should not done much of the heavy lifting, I would say. Next slide, please. So the effects of government spending. So increasing government spending have positive effects on output, consumption, private investment, and public investment, as shown in Figure 2. Output expanded in 2 quarters and sharply declined in its steady state. It's shown that the output is more persistent during episodes of technology shock. So if you will look at the previous slides, output is more persistent during technology shock compared to government spending. So when we say persistent, it means that the output increases longer before it go back to its steady state. Similarly, consumption in hours peaks, then decreases sharply. Both private and public investment increases in government expenditures spending shocks. This result replicates actually most of the prediction of the literature. BSP responded by reducing the interest rate and inflations, and increasing the deficits much muted during the shocks on government spending than on technology shock. Next slide, please. As shown in Figure 3, the price markup reduces output and consumption hours from impact until 10 quarters. Also, it increases both private and public investment for almost 6 quarters, and inflation increases by BSP responding with the inflation increase by raising the interest rates. Government debt increases, then decreases until 5 quarters, then move to its steady state. The last slide, please. An increase in, then the slide before that, please. Sure. On figure number 4, we see an increase in BSP policy rate. The increase in policy rate reduces output, consumption, and labor hours and inflation. It appears to reduce both private and public investment for short period and subsequently peak up to 5 quarters. In similar ways, there is a reduction in deficit for short period as a response to the raising of the BSP policy rates and rises until around 6 quarters, then die down. Last slide, please. Actually, when we're trying to do the simulations of the impulse response for rules number 1 and rules number 2 in alternative fiscal rules, actually there's no great difference or there's negligible difference. So both of them have the same impulse response functions. Lastly, we'd like to conclude with this particular topic with showing that there's an evidence that government public investment in infrastructures and have positive effect on private capital. It also suggests that the episode of increasing government spending, private capital responded positively. In addition, both private and public capital exhibits pro-cyclical behavior in the presence of government spending shock. The estimate also shows that the national government is more sensitive on debt to GDP than output or deficit to GDP in presence of government spending shock. And that concludes my paper, and thank you for listening and having time with this presentation. Have a great day.